Today's video is sponsored by Native Sons Goods, makers of premium quality guitar, bag, and camera straps, handmade in Albuquerque, New Mexico. Check out their website to order your own custom creation and play in style. And remember, when you support my sponsors, you support this channel, and I sure appreciate it. Hello everybody, Brad the Guitarologist here. Welcome to part 2 of a 2-part series on replacing motherboards and Marshall amplifiers. In the first part, we replaced a motherboard in this Marshall DSL Dual Super Lead 100. In this video, we're going to replace the motherboard in this TSL100 and also do some troubleshooting to make sure that that's all we need to do. So if that sounds like something you'd be interested in, stick around. Okay, here's the TSL up on the bench. Let's check this one out. I've got a brand new set of tubes on this side. These are the pair of tubes that were already in here. I fully suspect that this amplifier may also have had a pair of bad tubes, and it could be these over here. This one looks like it's taken some heat. Now this was a quad of tubes, so it should have been matched. So he was definitely having some problems somewhere, and this one has gotten hot somewhere along the line. So I look for possible problems here. Alright, here we are at our customary halfway stopping point, 64 volts on the input. We're only drawing about a half an amp, which is good so far. Here we're starting to creep up on the bias a little bit. Okay, dial it up a little bit more. Alright, we're 90 volts on the input. We're at 20 millivolts on this side and climbing. 16 on this other side. Got some noise at the speaker. This is a good sign. Alright, let's dial it up a little more. I didn't hear any of the relays kick in. Alright, there's 100 volts. We're at 0.87 amps. .43 millivolts on this side. I expect this one to be lower. Still, whoa, way lower. 22. Let's go ahead and dial this up a bit. Get that one to about 40. Okay, so we're at 40 and 40. So these are running cold at the moment. Go ahead and go up just a little bit further to maybe about 110 volts. Okay, 104 watts power consumption, 1 amp. 48 millivolts on this side, 46 on this side, but they're stable. They're not running away like the other one was. So at least we have some tubes that aren't shorted or anything like that. Alright, well this side on the bias is adjusted all the way up, so that's not a good sign. Okay, so it's going up to the 120 volts. Yeah, see, my bias over here is only at 55 millivolts. So something is definitely not right still in this amp. And I suspect it could be tube related once again. Go ahead and power down and see if we can, we'll stick another pair of tubes in here.
I was only trying to kill 2 birds with 1 stone.
I'm a little more worried about killing 2 stones with 1 pop here.
That's all that one coming. Okay, so very curious on this triple super lead. I've tried some different tubes. These are old test tubes. They're not brand new, but they are working condition, and they should have been fine in this amplifier, but they are not. This side still will not come up to bias. It won't come up past 50 something millivolts. This side seems okay, but this side still is not. So what we're going to have to do is take this thing apart. I suspect it's either something to do with this pot right here, possibly, or one of the other components in the bias circuit. Let's check out the schematic and we'll see what components in the bias circuit may be at fault here. I actually have a DSL schematic handy, and these aren't exactly the same, but in the bias they are very similar. But I want to show you this schematic because this is one that I had before, because the schematic for the TSL that I found does not include the bias board, and I happen to draw out the bias board on this DSL schematic so you can at least see what's in the bias board. And you can see right here from the pencil portions of this drawing, all that's in the bias board is just a couple of 22K pots. So I can pretty much exclude these pots. These are very, very low voltages that these even see, and there's minimal chance that it's going to be either one of these. So we'll reserve these for the very end. If there's a problem, if we can't find the problem elsewhere, we will open up this bias board and take a look at it, but I very, very seriously doubt that's going to be the issue. So we're going to look at other things. Now if we take a look down here at what is connected to that, we have an R77 on the DSL here, and it'll be a different resistor number on the TSL. Let's go ahead and pull out the TSL schematic so we can see from this point. Okay, here we go with the TSL schematic. And you're probably thinking to yourself, you know, this is a brand new board. Why would there be anything wrong on this board? And you're probably right. I am not really suspecting that this brand new board would be the issue, although I'm not ruling it out entirely because you just never know. But what I have done so far, just to recap, we know the issue was on this side with the bias not coming up on this pair of tubes. Now, initially I swapped the pairs of tubes around, and the issue stayed with the socket, so it's not the tubes. And also I put new tubes in, and I've put these old spare tubes in just to rule out anything else, and it is definitely not the tubes. I can say that pretty much with 100% assuredness at this point. So we can rule out tubes. Now, if we ask ourselves what is left, of course we do have the little 22K pots on the bias board, and it's possible that it might be one, but it's very unlikely. Like I said, low voltages, it's not likely going to be that. It may even be a mistake on this new board. Sometimes resistors do get mixed up on new boards, and they put the wrong resistor in the wrong spot, and there are capacitors too that sometimes are bad from the factory. But although I'm going to have to go through and systematically rule these things out. So like I said, here is the bias connector here on our DSL schematic. Once again, that's pretty much the same thing, but with those 22K pots that I've drawn in. We have R57 right there, which is, I think, a 220K. On this one, it's, yeah, 220K also, but it's R67. Is that the same number? Oh, it is R67, excuse me. R77 is a 10K. R77 on here they have listed as a 12K. The thing is, I think R77 is going to be, is it common to both? Let's see. I'm flitting back and forth here because it's easier to see what everything's connected to. And yes, it is common to both, so it's not likely to affect only one side. Now the only things connected, let's see, the thing connected to this wiper out of pin 6. Okay, so if we follow pin 6 and we follow it down, it comes down over to here and to R69 and also to C37. And also we have R5 right here. So these three components are exclusive to this one side that we have the problem on. And the other side, as we know, is working okay. R77 is the 10K, or 12K in this case, the TSL. Is that 10 or 12? It's really hard. I guess it is 10. Sorry, pardon me. That is 10. So what we'll be focusing on here is C37 I can't believe I'm having to troubleshoot this. I just put in the new board. What else could it possibly be? It could be something on the output, I suppose. Okay, so if we look at this pair of tubes, for instance, and we look at the biasing for these tubes, we can look at the cathodes. So we have this R6. Now this is my suspicion, because we have this R9 and we have this R6. Now we know which resistors those are because I've replaced those before in that DSL100 when I was originally trying to troubleshoot the board before we ordered the new board. But what we're going to have to do here is come in and look at R9 and R6 and make sure those are the appropriate values. I'm going to go ahead and pop this board open. We'll focus on R9, R6, see if those are the appropriate values. We'll also check the value on R69, R5, and C37. Alright, here we are back inside of this Marshall, and we're going to do some tests on some components. Let's go ahead and locate the ones that we want to test. I know R9 is right up in there, and R6 is right there. Okay, this one's 1.1 ohms, which is about what we would expect to see. And this one's about 1.16 ohms as well. So those are fine. Now next up, we want to check out R77, which is down here. Let's see, get a clear shot of it. It's right there. You see R77? It's that guy right there. Let's measure that one. Okay. And we've got 3.8K, but the thing is that might be impossible to read. It shouldn't be. I don't see any more paths to ground. Especially if we were to momentarily disconnect the bias board. Let's see about doing that. Whoa, wait a minute. I do see one problem right away. You see that? Do you see that white wire right there? That had come loose. That white wire had come loose. I bet you that's it right there. I bet that's why we weren't getting bias. So maybe it's a little simpler than I thought, and it was my error. Maybe I put that thing on a little too loosely. Cool. Well, I mean, I hate to know that it was probably my fault. But at the same time, that'll be good if that's all that is. Awesome. Well, let's fire that up. I'm curious to see if that fixed that problem. Fingers crossed, I hope it did. Okay, we have our tubes back in. On this side, these are brand new tubes, so I've replaced this pair. The other pair that was in here, I transplanted over to the DSL100 a little bit earlier, and they were good too. But so we replaced those. These are old, but that one looks like it's been warm. But they do seem to hold bias and test okay, at least when I've had this thing on so far. But so my old tester doesn't test EL34, so there's no I mean, I could do it with the 6L6 test and then just adjust things accordingly, but it really doesn't have the settings and everything for it specifically for an EL34. So the best way to test them is just to put them in the amp here and see if they work. So that's what we're going to do. Alright, we'll stop right there at about 67 volts, and let's go ahead and start taking some measurements. It'll take a second for the tubes to warm up anyway, but let's measure the side that we're really concerned about. Yeah, we're going to be in a much better position now because I'm at 46 millivolts already. I'm turning it back just a little bit because I'm going to go ahead and dial it up over there too, but we're only about halfway up on the voltage, so that's a real good sign. I think we're going to be fine. It was just a loose connector. Stupid me. Okay, so there's 75 millivolts on the problem side, and let's see if it takes off and starts going stupid again. I expect it to come up a little bit as the amp warms up. So what we'll do here is just let it kind of warm up over the course of the next, 15 minutes or something, and see if this changes very much. And if it starts to change on us or run away, then we know we've got a problem. But I don't think we're going to have a problem at this point. It looks... oh shoot. These are very touchy. So bias is holding stable so far, and we'll come back to it here in a few minutes. We'll let it burn in a little while. This rustling at the output is kind of concerning me. I think I'll go through and clean the jacks and stuff and just make sure we don't have some other issue. Could be that socket too. Okay, I'm going to fire this Marshall back up again because, again, I'm curious to see if that crackling that I was hearing was... let's see. I wonder if that's something that was maybe even due to the reverb being unhooked. I don't know. Because I did have the reverb knob somewhat up, so it could have been that maybe there was some noise being introduced there somehow. Don't know. Let's see. I'm going to plug a guitar in at the very least. It's the type of thing, it kind of sounds like it might be a resistor. I don't know. That almost sounds like it might be capacitor related, possibly too. Let's see. Well, there's one connector's barely holding on for dear life there. And that was one for the output, but that's not the problem. Let's try the crunch channel. The rustling is completely gone from the crunch channel. And also the lead channel. But it's back on the clean channel. So whatever it is in the clean channel preamp. Yeah, you can surely hear that. It could be tube related. That really could be tube related. I wonder which of the tubes. Let's see. Let's take a look at the schematic again here. Hang on. It follows the volume. If I turn the volume all the way down, it's gone. So it's definitely something pre-volume control on the clean channel. Post gain. The gain knob does nothing to it. So it's post gain, pre-volume. Let's see what it is. Connector 4. Okay, so whatever connector 4 does, and connector 10, it goes from 4 to 10. So whatever that is, I think what it's doing is it's it's just killing the signal from this board out to the rest of the amp. So I've isolated it, I believe, to this front board. The thing is, it's kind of hard to trace where this stuff is going on Marshalls because you've got connectors that go places. So you got the input here, and this connector 1 is taking this signal off probably to one of the preamp tubes. Right? Yeah, there's connector 1, so it goes through that gray wire down to there to connector 2 on that board, and then into that preamp tube. So all of that stuff is actually also in circuit, so it'd be hard to say definitively whether it's not one of those components as well. So you hear all the junk and noise there. I mean, this is a brand new motherboard, so it's highly unlikely to be anything on this board. Not impossible, but unlikely. Okay, so when it enters into this board, into connector 2, from connector 2, let's see what board. Alright, when it enters into the main board, the motherboard, from connector 2, okay, connector 2 right here, here we go. Pin 1 is the actual signal, so it goes through a 68K resistor into the first tube. It goes here through a capacitor and then to connector number 3. Right down there is connector 3, and then I follow that up, and that goes to connector 6 on this board. Alright, so connector 6, let's go back to our other board. Okay, clean channel board, connector, let's find connector 6. There we go, connector 6 right there. So the signal comes back after being in that first tube. Now the darkened lines are ground. So connector 6 comes in here, splits off into 2 different directions. It goes through this variable resistor that's controlled by this LED, and then on through a tone stack. So 220p into the treble, and all of that junk. It's after the gain. This volume knob right here does affect the noise. So when I turn this all the way down, it's cut off. So whatever is between the gain, which is here, and the volume, which is here, in the signal path, is the source of our problem. So it's something in between this point, right here, and this point right here. Now let's follow the signal chain a little further. Okay, when we come off this again, we go to connector 2. So let's follow that and see where that goes. Connector 2 is right there, and it goes connector 6 on the main board. So let's pick up connector 6 back on the main board. Alright, where are you, connector 6 on the main board? You're right there. Okay, so the signal comes back into this point, goes through a 470K resistor to here, comes over to this point, and onto V2. We come over through C15, through a 470. I'm curious, let's do some signal tracing. Let's check the plates of V2 and see if the problem persists on both of those plates. Got my probe here, and inside this probe there's actually a coupling capacitor, so I don't have to worry about the coupling. But let's go to pin 1, which is back there. You can see pin 1 on that Belton. I've got the signal running to my little test amp out here. Yep. Okay, so the problem does exist at pin 1 on V2. So that means that as of this point, we have the problem. Pin 7. Let's see if it exists on pin 7 of V2. Alright, so pin 7 on V2. Actually, it doesn't seem to exist now at all. But I pulled V2 and it appears to have gone away. Here, I'll show you. You know, there's noise right there, obviously, because that's my signal for my guitar. But there's no... There's none of that stuff. There's none of the rustling. Let's go ahead and put a new V2 tube in there. Okay, we have a new V2 tube in there. Volume's cranked all the way up and there's no rustling. So we definitely have a faulty V2 tube. So yeah, I'm confident we tracked that problem down. So this thing is ready to go. I hope you've enjoyed this little excursion into a Marshall TSL100. We changed the board and did a little post troubleshooting. So if you guys haven't already done so, please hit subscribe down below. Also hit the bell to receive all notifications. And for now, y'all take care.